So the old solution is the new problem, right? If you work on legacy code, you know what this means. It was a good solution once, or it was a solution in any case. The fact that it still exists is because it was a solution for some problem, and now it's a new problem. And this happens over and over. And this will keep happening, and this is going to happen probably to the thing you're working on now. How does that happen? A lot of problems are essentially coupling problems. We see something, we solve some problem by coupling it to something else, and now it's coupled, and it's fine because it solves the problem. But now the coupling becomes a new problem. How does that happen? Well, and why is it? Well, why is it a problem to begin with? Well, coupling very often leads to coordination problems. You want to do something, but because it's coupled to this other thing, you need to somehow coordinate how you're going to do these two things. You need to do two things at once, and they're coupled, so you have a coordination problem. And coordination problems are always more expensive. If you have to set up a meeting, the more people that are going to be in that meeting, it's going to be harder to set it up. And this happens at every level. This happens in code, this happens in architecture, this happens in business. So why do we keep having these coupling problems? Because if it's coupled in the heads of the business, it's going to be coupled in our solution, in our design, right? And this happens way too often. We tend to maybe overemphasize the domain-driven aspect, but we cannot just design a solution by blindly trying to adhere to what a domain is doing, because they're not doing it in a perfect way either. There are already layers and layers and layers of new solutions to old solutions that became a problem. So they have simple examples, like when a domain expert or somebody who has been assigned the role of domain expert, which of course is a lie to begin with. When a domain expert tells you, and then in the new system we will need a nightly batch to do this or that thing, this is already coupling to the old system, right? Because in the new system, maybe you don't need nightly batches, but the old system has become the domain in the heads of the users. So, the point I'm trying to make here is we should not just blindly accept what the domain is doing. We should challenge that, which is sort of what Yves was saying as well. Challenge inertia by asking questions about it and figuring out, does this really have to be this way? The way you're presenting this information to me, is this actually valid? Is this actually going to work? Or is this going to create coupling in the long term? Knowing that the old solution is going to become the new problem anyway. So what I did now is, usually when I do a talk, I run out of time and I have no time for my conclusion. So I moved my conclusion to the beginning of the talk. So I'm no longer coupled to the 15-minute limitation that I have, and I can just talk until and tell stories until time runs out. So now you know why I start with the conclusion. So I want to talk a bit about stories from actual domains. The hard thing, of course, is always to talk about the domain that you're not supposed to talk about in public, especially if you're going to say things that are a bit sensitive. So I'm a consultant. I visit lots of companies to help with modeling and design and architecture, this sort of stuff. And one of my clients is, they have warehouses and they do distribution of something. I'm not going to tell you what it is, but it's huge objects, let's just call them that. And they have a sort of traditional warehouse with, just people working there and doing order picking and put away, and they have trucks coming in. So all the usual stuff, all the sort of, superficially we would say this is the core domain. It's warehousing basically. Stuff comes in, you put it somewhere, you get it out, and you send it away. So, but they also have an automated warehouse, which is a lot more fun, of course. It's robots. It's really just, you're not even allowed in. You can sort of walk on the sites and see it happening, but you can't even go in there. But I was given a tour, and so it's really, I love watching this stuff. It's robot arms taking these huge objects out of the shelves and moving them onto conveyor belts and taking things off conveyor belts and putting them in places. And so we're just sort of admiring the show of all the huge robot arms. And I started noticing it, but the person I'm working with, or the person giving me the tour, is also saying, well, the reason I wanted to show you this is you're probably noticing how often these arms just move, to one place and then stop and then do nothing for a bit and then go back and wait and then go do something useful. So why are they? There's so much waste going on here. And this is sort of a process of multiple days of starting to look into this and talking to people and sort of doing all the things that you do when you try to approach a new problem like that. And it was very interesting because I was saying superficially the core domain is warehousing, but warehousing is a very generic domain. Again, superficially, but there's, as I was saying, it's stuff coming in, putting it away somewhere, being able to find it again, knowing where it is, grab it, and pack it and ship it. But the way they had, over the years, designed their software is for a whole different constraint, which is a much more interesting one. These objects are very heavy. And so a lot of the people I met there, they're very smart, wonderful people. But there's a group of people that they hire not for their intelligence, but for the muscle, of course, because they have to carry these things. So it's a different sort of selection criteria. So what had happened over the years is that maybe at first accidentally, but over time they became very aware of this, and they started designing the system specifically for basically being foolproof, right? Making it and running through all kinds of scenarios where you could, you would do some kind of process, and even if you make mistakes like accidentally scan the wrong thing or scan it and then scan it again or scan it and put it on the wrong conveyor belt or print a label and then put the wrong label on the object. So all of these sort of things that that could go wrong. So it was very much, the core domain in a sense became designed for being foolproof, right? And that's very interesting to me. This is sort of, Conway's law in effect. This is how the organizational structure and the communication structures in the environment influence the design of the system. And so you probably can sort of see where this is going. A lot of the existing system was used, of course, for the new automated warehouses. So they had all the robot arms were doing work that used to be done by humans, and a lot of the provisions in that system and a lot of the processes and hard-coded concepts in that system were designed to avoid human mistakes. But the robots don't make human mistakes, of course. So a lot of stuff was, it's sort of hard to explain this in a couple of minutes. But I have one example that maybe works. There was one user interface, and it's something like, I don't know if you can see this in the back, but you know what they look like. They're sort of these huge grids of, this particular one was incoming shipments. So it would show stuff like, a time and a shipment ID maybe, and maybe the gate and the warehouse where it was supposed to come in on a truck, and then maybe something about what was in there. And so what you would do normally is you would look at this, and when a shipment comes in, when the truck comes in, you mark it as confirmed, or maybe there's a couple of states. I don't know exactly what they were, but probably something like a truck has arrived, the truck has been unloaded, truck has left maybe, these sort of things. And then when stuff is unloaded and it matches the receipt and everything, everything that's supposed to be in there is in there, then the whole thing is confirmed. So all of this is just very normal warehousing. At some point, somebody asked for a feature. And the feature they asked for was to add an extra column here, which was quality control. And what was in that column was a number saying this is the amount of items from that shipment that will have to go through quality control. And this was something that evolved over time. They had a bunch of rules of, if one particular supplier often sends us damaged goods or imperfect goods, and we notice this, then we will do a lot more quality control on those. Or if we have a specific customer who complains a lot about the quality of the product, small damages on there, then if we know that items in this shipment are going to be sent to this specific customer, then we will do more quality control. So it's very much a sort of attempting to minimize the amount of quality control we do, but still do enough for the places where it matters. That's sort of the reasoning. So what happened was, okay, we have the domain or the people working on the floor. So it's the actual users, right? And they were actually very good at talking to them and meeting them. They would often go down there, or even people who, like programmers joining the company, would go down there and do the work for a while. So they know, they become a little bit experts. But so still what happened was, okay, we need an extra column with this number. And this became sort of part of the system. That column had to be there because it has always been there. And then when they added the robots, so one of the reasons the robots started doing all this unnecessary movements was turned out to originate here. Because what happened was, the assumption that was made was that when a shipment comes in, well, before it comes in, it's just listed here as a shipment that will come in. And so as long as it hasn't come in, there's no point in doing quality control, of course, because you can't. It's not there yet. So the assumption is that when you confirm it, then we can do the work of calculating how many items in the shipments will need to go through quality control. So this number would only appear after you click the confirm button. So what happened was, people working on the floor managers, they wanted to know the number of items that had to go through quality control before the shipment came in. Why? Because they wanted to know how many people am I going to schedule to be in quality control on any given time. Because they don't have a separate quality control department that just works all the time. It's people who do other work that are moved there temporarily to do some quality control, depending on the amount of stuff that needs to be checked, and also depending on, well, we have a lot of work. We're not going to make it, all of this stuff needs to go out before 5 o'clock. We're going to do only half of the quality control. That sort of, immediate on-the-spot decision-making. So it's all, optimizing for spending as little as possible on quality control, but still, keeping sort of the amount of complaints at a minimum. So what happened was, of course, I want to know in advance how many people I will need. So, and this number is not here yet, because they have seen, of course, that this number only appears because of these assumptions that you cannot do quality control before you have the product. The number doesn't appear. So the floor managers have figured out that, oh, if I click confirm, it appears. So if I want to know how many items I will need to control and how many people I just confirm. So they're like checkboxes, right? You check this, confirm, the number appears. Check this again, undo, the number disappears. You're laughing because you've seen this sort of thing. So now you can start imagining what happens, of course. For years, this is fine, because when you click confirm, nothing happens yet. And when you just unconfirm it, and it's fine, and the number is there now, and you can start planning. But now we have robots. The robots don't wait. The robots think, oh, this item is confirmed, so I need to go pick it up on the conveyor belt. So they start moving, and then there's an undo. And in the beginning, probably nothing happened even. There was an undo, but maybe they, I don't know, I wasn't there, of course, but they, I can imagine this sort of problem where the first time somebody clicks undo on a confirmed shipment, the robot just keeps continuing and then doesn't find the items and then stays there not knowing what to do, of course. So all of these sort of, and then of course what happens is workarounds. It's hacks upon hacks. It's, oh, we need to add an undo feature for the robot. So if it arrives, or we have to add a feature that if the robot arm arrives there and there's nothing there, it goes back or it waits for a minute or whatever. But so we're building up coupling and coupling and coupling, layers of workarounds coupled to lower layers and to older assumptions that were never challenged. The real problem here was only identified very late, which is we don't actually care how many items there are going to be checked. We care how many people are going to be available. It's an optimization problem, right? It's a resource utilization problem. If that had been identified much sooner, then maybe this column wouldn't have existed, but there would have been maybe a separate screen where you can sort of see the amount of work and compare, instead of looking at sort of a huge list of shipments that might come in, etc. You could imagine maybe some kind of separate user interface where it's more about calculating the amount of people we need on a specific thing or on a specific location, and then you could start building something that is, maybe it even becomes its own bounded context, which is purely about optimizing this usage of people and placement of people. So layers and layers of coupling. It's well, the old solution becoming the new problem. Thank you.